Okay, guys, let's get started. I have about a minute after, and we've got 20-some people here, so I think that's a good crowd.
Hi, this is Dave Krahl, and I'm here with Robin Clark, who does our training.
I work here at Imagine That. I've been here 19 years now, and do a mix of development and sales and support work. So if you don't know me from meeting me personally, you've probably communicated with me over through email. We're going to be talking about tools for troubleshooting, or how to debug your ExtendSim models. So some of this is general purpose that you could apply to problems in general, and some of this is specific to ExtendSim. So we'll be going through various things here. So the Simulation Masterclass will focus on finding the difference between what you want and what the model actually did. So we'll cover ExtendSim blocks, our debugger, developing your own debugging methods, and some other troubleshooting tools. What's our overview? Well, I've got some good news and bad news for you to start with. Then we'll be looking at block level tools, the debugger, some sample models. So we'll actually go through and debug some models, and I'll need your help with that, of course. We'll look at some other tools and how to develop your own tools and the debugging process. We'll have some random seed considerations, and I've got some random thoughts at the end that I find have helped me with the debugging process. So let's begin with the bad news. This is Greer's third law, and if you've worked with a computer for any amount of time, I'm sure you're aware of this, that a computer program does what you tell it to do, not what you want it to do. So the concept behind this is that you have to be very clear, and the computers are not going to second guess you. As hard as we've tried as developers, we've yet to try to figure out what you want rather than what you're actually instructing ExtendSim to do. But we do have some good news. So ExtendSim is very interactive. It's very easy to see the information in the model as it's being generated. So that's tremendously useful when you're debugging, as well as validation and verification. We have a wide range of troubleshooting tools available, and we'll cover most of those, and I may have missed them. So if you have any other suggestions or tools, type them in the question box and we'll review those. So this is not meant to be, this is the list I have, but if you have other things you want to suggest, I'd be very interested in those. The model logic is visual in ExtendSim, so you can see the relationships with the blocks visually, and that's tremendously helpful in the debugging process. And the source code for the blocks can be debugged. So if you do have a problem in a block you've built, or even in a block we've built, you can actually get in there and step through the source code of that. And that can be really helpful. And even in some cases where you're not looking at what that block is actually doing, but want to see the interactions between the blocks, that can be helpful as well. So what are some block level tools? Well, the history block is kind of our go-to block or tool for debugging. It records a history of the items as they pass by. So as each item passes by the block, we get a new row in the data table in the block, and we can see that over here on the right. And we'll see the time that the item arrived to the block, and then we've got, in this case, one attribute called ID, and we're seeing the value of that attribute as it passes by. And this is nearly always the first block I use when I'm debugging. So I'll toss this in a model and see how are the items moving through the model. I can take these tables that are in here, and sometimes I'll copy it over to Excel so I could look at them side by side, so I can have maybe a history block before an activity and a history block after an activity if I'm curious about something that's going on in the activity. So I'll copy those over to Excel, and then I can do some math on there so I can compare what's going on. An easy way to add a history block, because it's used so often, we've made it very easy to add the block to the model, is you can right-click on an item output connector and automatically add the history block, and it creates it kind of in this view we've got here in a viewing mode, so that it doesn't interfere with the items as they go by. And another feature that the history block has is you right-click on the block, you can clone out the table right below it. So it looks much like what we've got in the picture here, where you right-click, clone out the table, and then you'll see that right below the history block. So it's very easy to create these tables of histories of items as they go by. So we'll see some examples of that in a bit. So I'm going to go through kind of an overview of the blocks, and then we'll see examples of those. The record message block is another go-to block. It shows the value communication between blocks. So we can watch as a message comes into a block and the value that gets returned or generated by that block. And this is really valuable when you're trying to understand how the value library blocks are communicating with each other, as well as the value library blocks communicating with the item library blocks. And then we often use plotters, and plotters are a good first pass of doing kind of a gut check to make sure everything works properly. So even when I'm just validating the model, I'm making sure that what I put into the computer is what I think the computer is actually doing. And the plotter can show me relationships and ranges of variables and tendencies of variables and that sort of thing. If you want to look at the value in the database over time, you can use a read block and set that read block up to recalculate whenever that value in the database changes, and then you can plot that value out quite easily. It's also useful for comparing multiple values over time so that you can see the relationships between two different values in the model. Now, the pause simulation tool is something that I don't tend to use a whole lot, but I know a number of people here at Imagine that use, and as well as I think this is one that Robin likes to use as well, that will run the simulation to a certain point and then pause it, and you can step through the simulation with the step tool in the toolbar. And this can be useful for trying to see how the items are moving in kind of slow motion or having control over that. The link alert block allows you to see when the value in a database changes. So this can be useful for if you're writing values to the database and they aren't quite coming out the way you expect them to, then you can use the link alert block to monitor this. Item messages block is a little more advanced block. Now this allows you to actually see the communication that goes on between two item library blocks. Now, what's happening here is that the item library blocks actually have a dialogue between them that communicates whether or not the item can move from one block to the next. So let's say an upstream queue, an item arrives to that queue, it's going to send a wants message downstream. And then the block somewhere downstream of that is going to either answer with a needs or a rejects. And I'm not going to get into the details of this. It's covered in our manual, it's covered in Robin's classes. But these messages you can see in the item messages block, and so it's debugging at a bit lower level, so you can understand the actual dynamics of the communication between the item blocks as they propel the items through the model. So it's a tremendous tool for lower level debugging, and particularly if you're building your own item-based blocks, this is a tool that you almost certainly will be using. Now, the event monitor allows you to see what's going on the event calendar. So this is a table of the events in the event calendar, and the block name, the label of the block. So you see in some cases the blocks don't have a label, in some cases they do, and the event time and the event number. And the event number is a little harder to decode here, but the event time is quite useful, and the block that's actually getting the event is quite useful, so that you'll see that you can actually track which block has the next event time in terms of all the blocks in the model. So this is helpful if you're not getting events when you think you should be, or it can even be useful in a case where your model is running more slowly than you think it should. You can see if there's a lot of extra events there. There are other tools for looking at speed as well. Also, these blocks, I didn't mention this, but these purple blocks are all from the utilities library. Another block that's useful, not so much debugging, but every once in a while someone will come along and say, my model is huge. It's 700 megabytes in size, and I don't think it should be that big. Well, we drop a memory usage block into the model, and that will tell us what databases, global arrays, or blocks are using the most memory. So it's very useful for seeing what's going on there. And as often as not, someone's got a plotter in there that's plotting just a lot of data, or a history block, and history blocks tend to use up a lot of information, or a database that's just much larger than they thought it would be. So you can detect what blocks are taking up all the space, or model components, because it does include the databases and the global arrays as well. Any questions about any of those? Okay, that's a real quick overview of the blocks that we typically use. Now, one of the new features in 8.5, in version 8, was the equation debugger. And this allows you to step through an equation as it goes. So one of the features I often use is the test button. And this allows you to actually run the equation without running the simulation. So you don't have to always run a simulation model to go through the equation debugger and test your equation. And you can also put values in. If you look at the equation block, there's an input table of variables there. You can put values in there so you can test those values out. So you don't, it's a really good tool for trying out your equations without having to run the model and happen to have the right values there. That test button is really quite valuable. Another thing that you can do, and this is kind of a trick, is if you compile other blocks in your model, and quite often what we'll do is we'll just compile everything with the debugger on, then you can actually see by looking at the stack in the equation debugger. And the stack is the list of message handlers and functions that have been called so far. You can see what is causing the equation to be calculated. Because an equation can calculate based on a message coming in from any of its input connectors or any of its output connectors. So this is if you're having trouble figuring out why your equation is being calculated a particular amount of time, one trick you can do is to turn on debugging for everything in the model, and then using the equation debugger to see who generated that message. Now, also we also had for many years a debugger for the blocks. You can, if you build your own blocks or you work with our blocks, you can actually see in detail what's going on in the simulation. You can step through the blocks. You can step through to the point where if you get into the executive, you can see the event scheduling and how that's being determined. So you can get to a very low level, lower level than most people want or need to get to, but it is available for you. And again, viewing the stack is a way of seeing, what caused a certain action to happen in the model, and that, at least in our use, is often as valuable or more valuable than the actual stepping through the code and examining the variables. A useful function that you can use in your equations as well as blocks is the debugger breakpoint. So sometimes, let's say in onCreate block, you can't put a breakpoint in the block before you've created it. So you can put the debugger breakpoint function into a block in the onCreate block message handler. When the block is created, then it will pop up with the debugger where the debugger breakpoint function is called. Or maybe you want to have a complex condition. So there are conditions for the breakpoints, but you might want to have something that's more complex than what our conditions support. You could use the debugger breakpoint function to only break when that condition is true. So you actually put this in the code of the block, this debugger breakpoint function in there to pause the simulation at that point. So to use the equation debugger, you'll notice that if you're still using version 7, hopefully you aren't, but if you are, you won't have this option. But in version 8, there's a checkbox in all of the equation blocks that says enable debugger, and then a button next to it which says set breakpoints. And then when you do that, when you click on the set breakpoints button, you'll get this set breakpoints window come up, and you can click on the little, if you look at those little dashes on the side, if you click on one of those, then that sets a breakpoint. Now, what that means is that when the simulation, when it's executing that equation, when it gets to that point, it's going to pause, and the simulation will be suspended, and you can look at the variables here. For example, we can look at the value of count and random val and result and see what they are at that point in the equation. And then we can step through it. There are buttons you can click on to step through the equation. So once you've set that breakpoint, you'll also see the breakpoints window pop up, and this shows you all the breakpoints you've set in your equations. And you can double click to set a condition. And if you double click on that, now we've got a chance to put a condition on there and saying, I only want to stop, maybe I want to stop after a certain amount of time has elapsed, and that's at the top of this window. Or in this case, I want to stop when my random val variable is less than 0.25. So I've set this up to look at my random val variable, and I'm breaking when that's less than 0.25. Any questions about that? So let me go through some of the examples I've got here, and let's debug these. So let me start with this one. This was at Robin's suggestion, so this is a good example. What I want to do is record on attributes how long an item waited in the queue and what its processing time was. So does anybody see a problem with this just by looking at it? Raise your hand. We'll take a quick survey here. Does this look good to everybody? Okay, I'm not seeing any hands going up, so everybody seems to think this is a good model. Well, there is an error in here, and the first thing I might want to do is some initial model verification to make sure it's doing what I think it should do. So remember what I said my go-to block was. That's the history block. So let's put a history block in the model. And what I have is items being created. They go into a queue, and I've got an activity with a capacity of 5. And then I've got a set block where I'm recording the processing time and the wait time over here. And then a get block where I'm getting those values. Presumably we'll use them somewhere else in the simulation. So after I set them, I'm going to add a history block, and if I right-click on the item out connector, you'll see it says Add History Block. So I add the history block, and it stuck it on there for me. Now, I also want to see this while I'm running, so I'm going to clone the history table, and that put a little table in down there for me. So now I can see the arrival time, and I've got space here for one attribute, so I'm going to add processing time. I'm going to increase the size of this so I can also see wait time. And one more than I wanted. Let's do wait time first, since that happens first, and then processing time. Okay, so now what I'm doing is I'll see a table here of when an item arrived, what the wait time was for that item, and what the processing time of that item is. And remember, this activity has a capacity of 5. So if I run the model, and I've got animation on, we can see the items come through here. We can see them going into the activity, and I'm seeing some, I'm not seeing much going on there. That looks pretty reasonable. I'd expect my first few items to have 0 wait time. Okay. Now, does anybody see what the problem is? This little table has just showed me what the problem is of the model. What about this? Let me pause this right now. What about that item right there? That is the 5th item that goes through this. Right? That's the 5th item that's going into that activity. Now, the capacity of my activity is 5. So I would expect that at least for the first 5 items that my wait time is going to be 0. And this is what, with every model, you kind of want something that passes the smell test. Does this make sense? Well, this doesn't make sense. So what I might want to do is debug this a little further and say, well, why is it that I'm getting a wait time for an item that I would not expect to get a wait time? Now, it's possible that my model is correct and I'm discovering something about the system, but in this case, I've actually got an error in my model. So, Robin, any suggestions on what we should do? I'm going to put Robin on the spot. Any suggestions on what we should do next?
Well, Dave, having that connection line going across the activity is probably not a good idea. Usually we want to set those attributes as soon as we have them. What do you think, Dave?
I think that's true. Well, let's say I haven't figured that out yet. I'm getting started with ExtendSim, and I think that that those of us that imagine that have a magical ability to make the blocks do whatever we want them to do, not what we tell them to do. So what block would you use here to maybe debug this?
Oh, well, I would use my favorite block in ExtendSim, which is a record message.
Okay.
The ones that look like that one.
Oh, I lost Robin there, but we'll go with this. Let me stop the simulation. And let's put a record message block in here. So I've just broken the connection here. And the question I always get about the record message is, can you automatically add the record message like we do with the history block? We can't, because of the way that you have to connect the record message so that the value goes through it. You can't set it up just as a viewing block. So I'll put the record message in here. Okay, and now let's watch those values come through here. Now the record message block is reporting some interesting information here. Let's pause this and take a look at it. If you look at this, the first column says input or output, and that says which way is that message going. ExtendSim's messages are bidirectional, so they go both directions. So whenever an item leaves the queue, I'm going to get a message out the wait time connector, and whenever an item enters the set block, I'm going to get a message out both of its input connectors to set the value of the attribute. So what we're seeing here, a message is this in, it says it's coming out the wait time connector, and the output says this is the message that's coming out from the set block. So we can see right now we've got some wait times coming in here, and then some which are zeros, and then some messages coming out. So let's watch this run a little bit more. And actually every in message here is going to represent one item going through. Okay, let's pause that again and look at it, and let's see what the results are here. So we can see for the first, we scroll down. So this is our first item coming in, right here, our second item coming in. So that's 2, 3, 4, 5. So I've got at least 5 zeros of wait time, which is what I would expect. And then I get a few more items, so I'm up to 8 items going through without any wait time. So the first items go through without any wait time. That makes sense. And now I'm starting to see some wait times here. So I had a little queuing going on at this point in the model. So then I'm seeing an out message, and that says that this item, this set block, is requesting a value. So this set, if I count the out messages here, this is the first item that comes through, the second item that comes through, the third, the fourth, and the fifth. Now if you look at that, I've had more items come in, more values come in than values come being requested on the output connector. So what's happening is that basically my queue and my set block are out of sync. I'm looking at the wait time for a different item than the one that's actually going through the set block. So there's items waiting here in the queue, and there's items that are going through the set block. They're not the same item at the same time. And I can use this record message block to see the sequence of messages that are going back and forth and say, oh, I'm actually looking at a different sequence of communication between what's coming out of the wait connector on the queue and what's going into the wait time attribute on the set block. Any questions about that? And I do see some people a few minutes ago got the correct response on this. Yes, that the wait time is associated with a different item than is going through the set block. So it's a common mistake because it's easy to connect things up in all sorts of different ways in ExtendSim. That doesn't mean we completely prevent you from doing something that's incorrect. Good question. Rick Gilbert is asking, so if the activity capacity were 1 instead of 5, the structure would have worked even though it would not be a good structure. I have to think about it for a second. That would still be dangerous because you might have, you get into what's called a race condition, which is whether or not the item goes through the set block first or leaves the queue first. So you could be looking at it where you're off just by one item rather than off by a number of items. So in general, what you want to do is make sure that if you want a value from the connector and set it to an attribute, that you do it immediately so you don't have any chance for anything else. Yeah, well, Willie Weiss says, yeah, wouldn't it be off by 1? It could be. I'd actually have to look at it. It's a race condition where the timing, it might work, it might not. It's certainly not something I would recommend. And Rick did say, yeah, it's not good model structure to do that. But I would also recommend from a standpoint of making a model robust so that you don't want to create the problem in the first place, which is to say you build a model so that if you happen, even though it might work, but if you happen to change a parameter in the model later, that it's still going to work if you change that parameter, if that makes sense. Right. So the Rene Alvarez is suggesting that record the wait time as an attribute after the item leaves the block. The same with the processing time. So let's just fix the model very quickly here. I'm going to give myself a little space and take my wait time off here. Delete one of the rows. Oh, before I do that, I'll duplicate this block. So this is the correct way to approach this problem. So I'll set that to wait time. Take my wait time off here because I don't want to reset it back to blank. And now let's verify what we've done is correctly. So remember, we're looking for this fifth item, the item in row 4, and we want to make sure that at a minimum its wait time should be 0, and now it is. Now, another thing we could do with this, if we want to be a little more sophisticated, is actually to put a history block. It's a little tricky. We'd have to set up an ID attribute because the items can be out of order since this activity has a distribution in here. But set up an ID attribute, use a history block here, record the time that they leave here and the time that they leave here, and the time that they arrive. So we'd have history blocks so we could actually track every item as it moves through the model and calculate the wait time for that individual item. And I would use Excel. That's one model down. The next one is another common problem. What I want to do here is record to the database. I've got items moving through a model here, so I've got my same typical model. I create, queue, activity, exit, and then I've got some other blocks in here that are doing some housekeeping work. And I'm assigning one attribute, which is the count of the items going through here. So I've got an ID attribute. So the first item will have an ID of 1, the second 2, and so on and so forth. And then I want to write to the database what the wait time was for that item and what the processing time for that item was. So it's very similar to the last model. I've just instead of putting in an attribute, so I'm writing it to the database. And what I've got here is an equation block that when I come in to the equation, I'm getting the database index, the table index, the field index, and all of this information. I'm adding one more record. I'm inserting that record into the database, and then I'm setting the wait time and the ID in the database. Now, there's a number of problems with this model. can anybody identify, by looking at this equation, some performance problems that could be in there? That's one of the things. These are a little harder to track. Why is what I've done here not a particularly good way of accessing the database? I'll give you a hint. Yeah, Doug Shannon says multiple string lookups. That's exactly right. And we do see this a fair amount, so I wanted to bring it up. And that is that I am looking up all of this information every time the database executes. So what's happening internally in ExtendSim, and it always helps to take a step back and say, okay, when I put this into an equation block, what does the software have to do to figure this out? And if I had a model with a lot of databases and a lot of tables and a lot of fields, I'd really start to see some performance problems here. And the issue would be that every time the equation executes, ExtendSim has to look through the databases until it finds the model data database. And then it would have to look through all the tables in that database until it found the wait and processing times, and so on and so forth with all of these different fields. So what you really want to do in this case is use in our input variables the database index, the field index, the table index, and all of those, because that's going to be much faster. We recalculate it once at the start of the simulation for you, and you don't have to keep recalculating it. So that's one issue that's going on here. Okay, and that's a little tricky to debug. That's something that will be likely to be found by using the block profiler, where you're looking at what's taking up speed in the simulation. Well, let's run the model and look at the results. I'm going to use the pause sim block here.
Dave?
Yeah.
Dave, can I also make a comment on that, on what you last showed?
Sure.
Because I was one of the ones that used to do that all the time.
Okay.
But the reason was because some of those index had to change from run to run, or for various reasons. And how would you fix a problem like that if some of the indexes would change?
I guess it depends on how I want to do that. For one thing, for example, if I might create a I hadn't thought about the answer to that, Robin. It's a good question.
Well, actually, where I was leading you to was possibly putting into an include file and only doing it once at the beginning of the run.
That's one way to do it. Absolutely. Yes. So only checking those values once at the beginning of simulation run. Another way you could do it would be to create a table of values and calculate those, for example, once at the start of all of the runs, or put those values, in fact, in a database table itself, so that you access the database table to get the database index, and then have an equation block that calculates that once at the simulation run. So that's another way to do that. So thank you for stumping me, Robin. Okay, now I forgot where I was going with this. Bear with me one moment. Okay, I was going to put a pause simulation block in here. And, well, let's first look at how the model runs. We'll have animation on. Let's look at our database table. And, oh, let's watch this run. Now, what's happening here in this case? It looks like we're getting multiple records for every item that goes through. Anybody have an idea why that's happening? Well, let's look at our equation block. Let's go into our debugger and see what's going on. So we'll enable the debugger, and we'll say set breakpoints. And I've already got a breakpoint that's disabled there. So that every time this equation gets executed, we're going to stop at that point right there. So let's watch what happens. And I'm going to slow the animation down as much as I can. Okay, so an item moves into the queue, and then we're getting a value out of that wait connector. So let's step through that. And we set our values in the database. Okay, that looks good. And then let's see what happened next. So wait a minute. Now we're getting another value here, another calculation of the equation. And this happened, and I'm stepping through the code here, because an item moved into the set block, or the get block, where we're getting the ID. So what's happening is that this equation is executing once when we're connected to the wait connector and once when we're connected to the get block. And I can see this for every item that moves through. I'm getting 2 calculations of the equation. Now I've got a static variable here. This record count is counting up every time the equation is being executed. So that's not a great way to build an equation block where I've got multiple things connected to it, and I'm just adding records to it every time it's being evaluated. And if we look at our database at this point, we can see our double records here. So our ID is we got 1, 1, 2, 2, 3, 3, so on and so forth. Actually, what we're getting is pairs of values because the ID doesn't get updated until the item actually leaves, goes through the get block. So what we've got here is something that's kind of unreadable. Well, let's try fixing this. And one thing we can do, and this goes back to Doug was asking a question earlier about how to control the messages. One thing we can do is control the equation to say I only want to execute whenever I get an input on a certain connector. So in the options tab of the equation block, we can say, well, I only want to respond when I get a message on the ID connector, and I don't want to respond when I get any output connector messages. I don't have any output connectors here, but now I can control very precisely when I'm getting a message. So let's watch this run. Oh. So reset our. Let's run it without the debugger on there. And now if we look at our database, we can see we're getting 1 record for each item as it moves through. Now, one thing about the debugger is you want to make sure that you turn it off when you're all done. Now, this model has another issue in it. And let's turn animation off, and let's say we want to do some analysis. And if we run the model, watch carefully over here, watch the simulation runtime. I left that on. Okay, watch the simulation runtime carefully. You notice that's not decreasing. We're staying at 2 minutes. That takes a long time just to process about 10,000 items. If we run it again, we'll see it. It takes quite a while to run those 10,000 items through there. And one key factor is that it's not, the time to complete the run is not decreasing linearly. It seems like it's taking always a little longer than it estimates. So a tool I might use to figure this out is the profile block code, and this is very useful, and I recommend that you run it on any model you build. It only takes a moment to turn it on. So if you go to run debugging profile block code and then run the simulation, it'll take a little longer to run it, but it's going to tell us what blocks took the most time out of the simulation. So it generates this file, and it says, we get a table here, and it says it takes 89% of the time was in one equation. So it looks like I've got an equation that's really inefficient, and that's equation number 16. And an easy way to find that is to show the block numbers And there's my equation block number 16 right there. Okay? So if I look at that equation, we're doing the same thing we were doing before. We're getting all of these variables. Remember I said that was slow. And I'll give you a hint. In this model, because there's only one database, that really doesn't take up much time. It's only when models get bigger that it starts to take up time. But I'm actually doing a DB record find in the equation block, and that's going to be very time consuming. So you want to look for these sorts of things in the model where you're doing lookups or finds or that sort of thing in the equation. Those can really slow things down. And in fact, a better way to put that together would be just to use our ID rather than searching for the ID, using the ID directly, because we don't actually need to do the search. Okay. Let me bring up one more model. And just to give you an idea, this is a much more efficient way to do this. Rather than having the equation blocks write out the values, I just used the write I block to write those out. So that's a much simpler block. I didn't have to write out the equation to do that, and it's much more efficient. If we run this, you'll see it just runs very quickly, and it gets our 10,000 items through in almost no time. And if I look at our database, it makes a lot of, it's got the correct values in there. Okay. All right, I'm running a little short on time. So let me get into one other equation problem. And this is the debugger that we'll be looking at here. And in this case, what I've got is a random value, and I just want to count the number of values that are less than 0.25. So I'm just doing a calculation on my equation here, and I want to count those values, or keep track of the number of values that are less than 0.25, and then I'm taking the average of those over time. So if I run the equation, if I run the model here, you see that I'm always getting a mean of 1, even though in my random number block, if we watch that run, I can see I'm getting all sorts of different values, but it's saying that everything is equal to, I'm getting a variety of values here, but I'm only getting 1s out here. So let's step through the equation and see what's going on. Well, the first thing I might do, and remember I talked about this, is use our test button to see what's going on. So I can run the equation without running the simulation. So I'm going to put a possible value in here. Let's put a value of 0.1. And in that case, I should get a count of 1. So let's test that. Let me turn on that debugger, and I'll set a breakpoint. Okay, so I've set a breakpoint so we can see what's going on there. So random val is the name of the input variable that's coming in through the connector. And if I test this equation, and I'll step through it, and I initialize count is equal to 2. Okay, that makes sense. And I look at random value, and that is 0.1. Okay, that makes sense, right? So is 0.1 less than 0.25? Yes, it is. So let's take another step. And I get a count value of 1. Good. So that seems to be working. And I say result is 1 over count, and result is equal to 1. Perfect. Everything works in that case. So let's try another value. Let's try 0.5. Now 0.5 is greater than 0.25, so I should see a result of 1 over 2 in this case, or 1/2. So let's test our equation. So I have count is equal to 2. That makes sense. Is our random value of 0.25, is that less than 0.25? Yes, it is. Or, I'm sorry, no, it's not. So we should see our count change to 1. Oh, wait a minute. Okay, I'm sorry, I misspoke. 0.5 is not less than 0.25, so I should not be executing the statement. So does anybody see what's wrong with that statement? Robin, any suggestions?
Oh my, Dave. I see what the problem is. However, this is the one that usually takes me a few hours to debug. You might not want to ask me about this one.
Yeah, I'll give Rick Gilbert and Dave Jenks gold stars for finding this, because this is a common problem in C-based languages, C++, C, Mod L languages that are based on that, which is because statements end with a semicolon. It's real easy just to drop in a semicolon at the end of an if statement, and that's what we've got going on here. So let's fix that. We have a semicolon at the end of this statement which says, okay, I'm done with the if, and then no matter what happens, I'm always going to execute the next statement. So let's take that semicolon away. All right, so let's fix that. And let's set our breakpoints and test our equation. Let's see if that works now. Okay, so count is 2, random value is 0.5. There we go, now we've skipped that. So now our result should be, oh, Willie Weiss got it too, okay. And Doug Shannon. So we've got a bunch of people that I'm sure have made this error before. Of course, I never have, but you know, that's. So our result in this case should be what? Should be 0.5. Well, let's take a look at it. Our result is 0. Since when does 1 over 2 equal 0? Anybody know this one? Robin? There we go. Willie Weiss got it. Because we're doing integer math here. So our count is an integer. 1 is an integer. When we take 1 over 2 as an integer, we get 0. So let's fix that.
Dave, I've seen that one before. I've done it before, but and I keep doing it. So I'm a bad one to ask for that sort of problem.
So all we have to do is change this to a real, and ExtendSim is smart enough to say, oh, I've got a real number in here. I'll just evaluate the whole thing as a real number. And we'll do this again. Test the equation. Step through there. And there's the result we wanted is 0.5. All right, so Bart Bennett got this as well. Doug Shannon got this. Willie Weiss. So a bunch of people saw this one as well. So this is how we can use our debugging tools to discover what's going on inside of equations. These are mistakes that I've seen experienced programmers make. It's very easy to get the integers and reals mixed up and accidentally drop that extra semicolon in. Those are common mistakes in C-based languages. So let's run our simulation now. We'll turn off our debugger, and we'll run it. And now we've got a value that seems reasonable. So if we're looking at a random value between, in this case, 0 and 1, and we're calculating the proportion of those that are greater than we're getting 0.25 as a value if they are less than, I'm sorry, 0.5 if the value is less than 0.25 and 1 otherwise, then that seems like a reasonable value for that. Okay. So I'm running a little short on time here. I'd hope to have more time for questions. But some other tools, animation, which we used in our example, all of our examples, is a great way to see what's going on in the simulation, and that's a first pass along with the history block. We use cloning quite a bit, so we can see the values as they change, and we can see the important input parameters that will clone out those values so we can see what's actually going on in there. Also, I recommend doing a do-it-yourself statistics. This is useful for model verification as well, so that what we think we put in the model is what the model is actually doing. So particularly as you're getting started, or if you're calculating something that's important, or you're not quite sure about how it should be calculated, for example, the average wait time, you can calculate with a mean and variance block as well as looking at the statistics in the queue, so that you can compare those two statistics and they should be the same. Trace files are something I don't use so much simply because they tend to have a lot of extra information. But one place where they're really useful is if you have two models that you think should be doing the same thing and they're doing something different. So once in a while, for example, between versions, we'll see some model will change behavior between versions. We'll run the trace file in two versions and use a diff tool like WinMerge to compare those two trace files. I talked about WinMerge. So WinMerge allows you to compare two files, and if you can generate a text file, so you could write information to the database, you could use the trace file, you could generate a block report. WinMerge can tell you what the difference is between those two files, and sometimes that can give you a clue as to what's going on in the model. We looked at block profiling, and that is if your model is not running as fast as you think it should, turn on block profiling and it will tell you which blocks are the slowest in the simulation. And I recommend it in any model because you may just discover a way to speed up your model, and generally if the model is running faster, that's going to make your life a bit easier. So we also here tend to develop some of our own tools, and this is where most of those tools in the utilities library are tools that we developed for our own debugging purposes. And these are ways of creating your own tools for debugging. One way is to just record information to the database. So you can have write blocks that write information to the database as the simulation runs. In version 8.5, which is coming out before too long, we're finishing up some features in it. We're going to have a logging feature, so you'll be able to see as items move through the model, you can see in a database table those items as they move through the model. And you can do it in a selective way, so it's more useful than a trace file, which just gives you pretty much everything that's going in the model. The logging feature gives you some filtering tools so that you can generate reports based on that. The equation blocks can be used. So for example, you could put in an equation block that you pause the simulation if the value is greater than a certain number. You can create custom blocks. So there's nothing wrong with building a simple block if you've got programming expertise that watches values in the simulation and responds to them if they're out of range, for example, or reports them in its own table. And this is, for example, the record message block was a custom block that we built for debugging models that we found would be useful to all ExtendSim modelers. So I'm not going to go through this because I'm running out of time and I wanted to leave time for questions at the end, but back in 2005 I wrote a paper on debugging. I actually merged information from simulation modelers and from software developers so that it has elements of both of those areas in there. And I found it really helped me once I wrote out this debugging process. It helped me to become a better debugger, to understand what was going on in debugging. So the process basically is you want to duplicate the problem and then describe it. Duplicating is very important. You want to run the model so that you've got the same result every time, so that you're not trying to, play whack-a-mole where the problem shows up in a different place every time you run the model. Describe the problem. So it's a good idea just to sit down and say either to yourself or someone else, what is the problem, what's going on. It's important to always assume the bug is yours. That'll save you a lot of embarrassment in the future if you're always blaming someone else for the bug when you do indeed find out it is yours. Divide and conquer, so split up the problem into smaller and smaller pieces, particularly if it's a large model. If you can reduce it to a small model, it'll be very easy to solve it. Think creatively, so realize that the problem may not always be what you suspect. So try to keep an open mind. Leverage the tools, and I've talked about what tools we have in ExtendSim. Start heavy debugging, which is to focus on the problem. Kind of close your office door, get into a quiet place. I like to listen to music while I'm debugging, whatever works for you. And then verify that the bug is fixed to make sure that it's actually the model is behaving the way that it should be. So try some sensitivity analysis, some different values to make sure that everything you try still works properly. And then if it's a problem that you think may be common, share it with other people. Send it to us, and maybe we can figure out a way to help people avoid the problem in the future, or share it with your coworkers. One other common issue with simulation is that most models will have randomness in it. Once you've identified that there's a problem in the model, the first thing you should do is to fix the seed so that you can reproduce that problem. So every time you run it, it occurs at exactly the same point. And then make sure you, after you fix the problem, turn that off again to make sure that the problem is fixed under different conditions or different random conditions. Some additional thoughts: preempt the bug. Make sure that you build robust models that don't have problems in the first place. So even though you think something might work, if you think or you believe that changing some parameter in the model will make may make the model work improperly, figure out a different way to build it so that it's very robust, it's very solid. Robin says build pretty models, so this is part of that as well. A model that's easy to understand and see and is well organized is much less likely to have a bug in it. Build an error checking so that you can put something in an equation block, for example, that if you know that a value will be out of range, a particular value is out of range, stop the simulation, call the abort function, and stop the simulation. At that point, you can pop up an error message, and that'll help you avoid problems later on. I talked about printing models. Use debugging tools even when you think the model is working properly. So there's nothing wrong with putting some history blocks in the model just to see, okay, is this doing what I think it should be doing? That's part of the model verification process. If you do see that the model used to work and doesn't work now, look for what's different. A lot of times people will tell us, well, it used to work, I didn't change anything, and now it doesn't work. Well, something changed. So look for what has changed from one iteration of the model to the next. Make one change at a time. Use a rifle, not a shotgun. We're not doing design of experiments here. We're trying to find out what the problem is. So if you change a lot of different things at a time, it's going to be hard to figure out what actually made an impact on the result. Test your solution. I mentioned that earlier. And don't blame someone else until you're absolutely, positively, totally sure that it's actually someone else's problem. Thank you very much. Sorry, I ran out of time there. I spent a little more time on the examples than I thought I would. Do you have any questions? Okay, well, I appreciate all your time. If something else comes up, feel free to email either myself, and if I could volunteer Robin to answer questions as well, you can contact him. Our emails are pretty readily available out there, and appreciate your time. Thank you very much.